Hello everyone, this is Rajesh Pandey and today I have some questions from International Mathematical Olympiad. These are conducted and one of the, you can say, the reputed examinations to for talent acquisition or to recognize the talent of a student. So this topic you might have studied in class 8 and 9. This topic, the questions covers the topic of indices, sorts and indices. So basically I would like to do for you and I will suggest that whenever you see such questions and you are in the practicing mode, put some pressure on your mind and evaluate the things that you can do. I am showing you some examples. I know, seeing the question, that 3 raised to the power x plus 1 plus 3 raised to the power 2x plus 1 sum to 270. It means there are some numbers which has been evolved or which has come on raising some power on 3 and they sum to give 270. So I have in my mind that I know what I know. I know that 3 square that is equal to 9, 3 cube that is equal to 27, and similarly 3 raised to the power 4 is going to be 81 and 3 raised to the power 5 that is going to be 243. If we go ahead, 3 to the power 6 that is equal to 729 and so on. So being a child or being a student of class 8, 9 or 10, and if you are very eager to know the things directly without any calculation, you have to develop some charts like this or it will be given in the classes. So I think as I have developed this thing, you are getting a little bit idea about this. As you see, if we add these two numbers, what we are getting? 243 plus 27, that sum up to 270, and we have almost our answers. Like this could be 3 raised to the power 5 and this could be 3 raised to the power 3. So by using this technique you can easily find out the value of x. You can say that x plus 1 is equal to 3, so x is going to be 2, and this 2 is also satisfying the second format. 2 into 2 plus 1, that is going to be 4. So if you know some data, you can easily jump on the answer and x will be equal to 2. Similar is the case with this one also. If you know the expansion of several powers on 2, you can sum up to them and can find out 224. So I will suggest that try at your home. Now, what if we don't have time or there is hectic schedule in attempting such questions, then we must know the exact method of coming to any conclusion or solving the proper question. So we will apply the method of indices. So what the indices say? What are the indices? Indices are the powers on any particular number and they say how many times that particular number has been multiplied with itself. Similarly, if we have some bases same, like suppose 3 raised to the power 5 into 3 raised to the power 8, bases are same, so the powers will be added, that will be equal to 3 raised to the power 13, you might have studied. Similarly, if we have 5 raised to the power 4 divided by 5 raised to the power 2. When there is division and the bases are same, the powers will get subtracted and we will be getting 5 squared. So these are the things that we have studied. Now we are going to apply the same concept in the backward way, or you can say in the back gear. So suppose the power on, I am solving this question, the power on 2 are in different forms. There are some plus cases, there are some minus cases. So we can split in the backward form since the power has been in the negative part. So you can write 2 raised to the power m divided by 2 raised to the power 1 plus 2 raised to the power m plus, now 2 raised to the power m, and here the plus 1 is added, it means it must have been multiplied. So you can write 2 raised to the power 1 in the multiplication format, and we have 2 to 4. Now what we can take common? We can take common by the algebra 2 raised to the power m, and we have 1 by 2 plus 1 because there is nothing here, and 2. So finally what we are getting here? We are getting 2 to the power m into 3, 6 plus 1, 7 by 2 raised to the power 2 to the, that is equal to 2 to 4. So we can write 2 raised to the power m is equal to 2 to 4, cross multiply 2 divided by 7. And if we divide this number by 7, 7 3s are 21, we are left with 1 and 2. So 32 into 2, that is going to be 64, and as we know it is 2 raised to the power 6. So finally what we have m is equal to 6. Why so? Because when we are getting any format like this, if a raised to the power x is equal to a raised to the power y, a is not equal to 1, in that case we can say that x will be equal to y. These are the certain rules that we study in class 9. So by using such things we can do it manually, or what I have said earlier, you can develop some things on as your homework to directly jump on the answer part of the particular questions. And these two questions belong to the IMO. So I hope the solutions and the approaches will be very useful to you. One of the important, or you can say very selective question of different type of examinations which are asked on the basis of the syllabus of class 9 and 10. So in this figure that you are seeing, it is a right angle triangle ABC, and in between that we have PBQR. This is a rectangle. Now the part that has been given is AP is 8 centimeter or 80 units, and QC is equal to 3 centimeter, and we have to find out the area of rectangle PBQR. So obviously whenever we see such type of embedded figures, then usually being a child, we start to think what we have to do, what concept we have to apply. So whenever you are having any similar type of figures, like you have a triangle here, you another triangle you have here, both are right angle triangle, because initially it was a right angle triangle, and the embedded figure in between them is also a rectangle. So all are connected with you can say right angular. So there must be some similarity among them. So think over it, and as we have studied in class 10 syllabus, the similarity of triangles. So what the similarity of triangles says, how you will build up the similarity of triangles. There are two criteria that we can go for, that is AAA, angle, that is two triangles should be equiangular, their corresponding angles should be equal, then it must be a pair of similar triangles. On another basis, you can say if the sides are proportional to each other, their corresponding sides are proportional to each other, they also can be called similar triangles. In the same way, there is another criteria also, that is SAS, where we see the proportionality of two pair of sides and the equality of angles between them. That is called SAS criteria for similarity of two triangles. Now, as I had stated earlier, I am seeing two right angle triangles here, and in these two triangles I am going to build up the concept of similarity here. So what I have one triangle as APR, triangle APR, and another triangle that I have, that is called RQC. Now, why I am writing in the pattern? Why so? Because the angles opposite to the corresponding part should be equal. It means angle A should be equal to angle R, angle P should be equal to angle Q, and angle R should be equal to C. What I am saying here, APR and RQC. Yes. Now, start to build up the things. This angle is right angle, so angle Q and angle P are same. Similarly, these two lines are going to be parallel. Why so? Because this and this both have right angle, and by the corresponding angle property, these two lines are going to be parallel. I mean to say that RQ is going to be parallel to AB, and with the concept of corresponding angle, these two angles are also going to be equal. So what we have in two triangles, that is in triangle APR and triangle RQC, we have angle P is equal to angle Q, that I had already denoted. Now what about angle A and angle R in this? These are also going to be equal. And in any two triangle, if two corresponding angles are equal, the third is going to be equal. Why so? Because sum of interior angles of any triangle is going to be 180. If two parts are equal, the third is going to be obviously equal. So by AAA property, we can say that these two triangles are similar to each other. This is the sign of similarity. And what we apply here, since we know if two triangles are similar, then the ratio of their corresponding sides is going to be equal. So let's see what does it come from this property. If we take AP, then we have to take RQ. So AP upon RQ is equal to PR, that will be taken with QC. There is no need of taking RC and AR. So AP upon RQ can be written as equal to PR upon QC. Now put the values. If we put the values of these things, AP is what? That is 8, and RQ is A. Similarly, PR is going to be B, and what is QC? QC is given 3. So what we have to find out the area of PDQR. PDQR is a rectangle, as I have stated. So area of rectangle will be equal to the product of their two adjacent sides, and two adjacent sides has been given as A and B. So basically in this question we have to find out the value of A into B, and from this relation we are getting AB is equal to 24 square units, as no units has been given, so we will write square units because area is always expressed in terms of square units. So what is the trick that we can develop from here? Whenever you get such type of questions and these parts are given and you have to find out the area of the individual figure, just multiply these two and you will be at your answer. So I think this trick will be also useful for you. Now jump to the second question. In the second question, we have a rectangle ABCD and we have two circles touching each other externally, and their diameters are going to be, I have not named this one, but their centers are P and Q, and we have to find out the area of triangle PQR. We are not given the radii of either of the circles. Only the given information is that area of ABCD rectangle is 15 centimeter square. Now we have to find out the area of triangle PQR. What is a triangle PQR is? First of all, you have to look at it. As we know, the circle is being touched by one of the side of rectangle, that is AB, and Q is the center, and as we know by geometry, the radius is always perpendicular on the tangent. The radius is always perpendicular on the tangent, so QR is always perpendicular on this. And this is going to suppose X, the radius of the bigger circle. So if this is X, similarly this also going to be X. And QC is also going to be the radius of the circle, because this one is the diameter. Suppose I put another name here, K. So KC is going to be the diameter of the circle. So in this case QC is the radius, so this can be also taken as X. So what we have here, QC is X, so KQ will be also X. Now if I see the smaller circle, suppose the radius of the smaller circle is taken as Y. So PK is radius of a smaller circle. Similarly, PD will be also the radius of smaller circle. Why so? Because this part AD is going to touch this circle, and the tangent is always perpendicular to the circle. Similarly, the radius is always perpendicular to the tangent. So applying these concepts, the tangents will be perpendicular on the radius, or radius will be perpendicular on the tangent at the point of tangency. I have done these things. So we can come on certain conclusion. What? ABCD is a rectangle, so this is also going to be X, and the whole DC, what we have, DC is going to be 2y plus 2x, we can say, and AD, as we have supposed, that is equal to X. So area of a rectangle ABCD can be written as the product of two adjacent sides. So it can be AD into DC. So here we have what we have. AD is X and DC is, you can take 2 common, it will be X plus Y. So this is twice of X plus Y. So the whole area, that is twice of X into X plus Y, and that has been given from here, 15 centimeters. Now what is our task? Our task is to find out the area of the triangle. The area of triangle, which is also a right angle triangle, as we have said earlier, that tangent is always perpendicular on the radius. So this angle is 90 degree, and these two sides are the part of rectangle, and the rectangles are always, the sides of rectangles are perpendicular to each other. So this one, this triangle is going to be a right angle triangle, and the area of right angle triangle, that is the triangle PQR, can be written as 1 by 2 of what side? RQ into PQ. So 1 by 2, RQ itself is going to be, RQ will be just equal to X, and PQ, the distance between the centers of the two circles touching externally, and the distance between the centers of two circles touching externally will be the sum of their radii, as we are seeing here. So it will be equal to PQ, that will be equal to x plus y. So now we have some values of x into x plus y from here, that we can write x into x plus y is equal to 15 by 2 centimeter square. And similarly, the area of triangle PQR is going to be 1 by 2 into, in place of this we can write 15 by 2, so 15 by 2 centimeter square. Finally, we are going to have the 15 by 4 centimeter square. You can write it as 3.75 centimeter square, which is the required area of the triangle. So this is also one of the important questions that is taught, or that we generally teach for the batches where the students are preparing for different competitive examinations like Olympiads and NTSC and all these. So these are the things that is the conglomerate, or you can say the mixture of several concepts that we study under the syllabus of class 8, 9 and 10. Thank you.